Hello, good morning students. Welcome to BYJU'S exam prep. Very good morning all of you. I hope everyone is fine, good. Okay, so today we're gonna have a quick rapid fire session, the top 20 questions from the entire syllabus of theory of machine for ISRO examination perspective. So before starting the session, please do let me know whether my audio and video all good, all perfect. Good morning, very good morning. Let me check from my end also. Yes, very good morning, Avnish. Okay, good morning, good morning. एक बार यार बता दीजिए all good with audio. Yes, thank you. One second. Yeah. So I hope everyone is good. As you know that in the line we're having lot many examinations and the level of exam will be almost similar. If you talk about ISRO or if you talk about HAL, है ना? So almost the same level of question will be asked. As calculators are not allowed, so you won't be getting a calculative problem. Okay, so it's very important you try to focus on the pattern of questions also. Like in different examination the pattern will be slightly different. ठीक है, तो उसके हिसाब से you need to practice or else it will be like the time will not be you won't be able to utilize the time effectively. Okay, चलिए, very good morning, very good morning, good morning, चलिए. So as you know that ISRO के लिए almost every weekday we are having at 11 AM this session going on. So I took this specifically for the theory of machine so that if you have studied theory of machine, we'll be having a quick revision through the questions. Okay, so I hope everyone is good, fine, and everyone has connected with me on my Telegram channel, that is Learn with Suraj, right? And Rakesh sir and Dheeraj sir will be coming up live on 8th of August. Okay, 8th August, that is tomorrow at 7:30 PM, and they'll be talking about the topper's blueprint to success in GATE 2024. Okay, and for joining this free workshop, there's a link in the description. You can definitely register yourself. Okay, so can we start with the first question? Yes, can we start with the first question? Everyone, please do write in the comment section. बिल्कुल quick response आना चाहिए. We'll try to cover all the 20 questions in the next 30-35 minutes, है ना? So I want everyone to be super ready and just leave whatever doing right now, leave it aside and just focus on this session for the next 35 minutes. The first question is on your screen. In a crank and slotted quick return motion mechanism, the distance between the fixed centers is 200 mm and the length of the driving crank and the slotted bar are 100 mm and 500 mm respectively. What is the length of the cutting stroke? They're asking you what is the stroke length. What is the stroke length? Quickly, we know a direct formulation. This is a crank and slotted quick return motion mechanism. First of all, tell me which of the link is being fixed. कौन से लिंक को फिक्स करते हैं? We are fixing the connecting rod, है ना? Connecting rod, it's being fixed for this particular quick return motion mechanism. This is center 1, this is center 2, right? This is your crank, this is the slotted bar. We're having your slider, which is having a sliding, something like this. Okay, this is, let us say O, this is O1. Now in the question they are given the distance of O1 OS 200. This is the fixed link, which is the connecting rod. Okay, so O1, that is the length of the connecting rod, that is equal to 200 mm, right? The length of the driving crank, the radius, this is R is equal to 100 mm, right? And the slotted bar length of the slotted bar, that is O, let us suppose P, OP, that is equal to 500 mm. Okay, so quickly tell me what is the value of the stroke length? What's the value of the stroke length? This one. This is a direct formulation. This is your stroke length. P dash is the stroke length. P dash is the stroke length. Quickly. Very good, Kiran. Absolutely correct. We know a simple formulation that twice the length of the slotted lever, a slotted bar, into the radius of the crank divided by the length of the connecting rod. है ना? So 2 into length of the slotted bar is that is your 2. We can say 500. Radius is 100 divided by 200. Solve it, you're getting exactly 500 mm as a correct answer. Option C is the correct answer. Very good morning Kiran. Option C is the correct answer. 500 mm is the stroke length of this particular quick return motion mechanism. Done? Yes everyone. अरे हाँ ना बोलो भाई, yes है ना, all good. I told you for the next 35 minutes, leave everything aside and let's focus on these questions, because I have taken the questions from the entire syllabus, the top 20 question from ISRO level, the ISRO examination level. Okay, chaliye, next question on the screen. Question number 2 is very easy from your mechanism topic. Which of the following pairs are correctly matched? Select the correct answer using the codes given below. So they are saying they have given some combination of mechanism and the chain from which it is being delivered. So which of the combination is correct? Whitworth quick return motion mechanism, single slider crank, Oldham's coupling 4-bar chain, and Scotch-Yoke mechanism is a double slider chain, crank chain. Which of these combinations is correctly matched? Quickly, it's a very easy question. A, B, C or D? Very good, Kiran. Avinash? Yes. Simple question, hai na? It's a very easy question. Option C. If you see the Whitworth quick return motion mechanism is an inversion of a single slider mechanism. Oldham's coupling is an inversion of a double slider crank mechanism. Double slider mechanism, right? So ये तो गलत है. It is not a 4-bar chain. Scotch-Yoke mechanism, it's definitely a inversion of a double slider crank chain. So 1 and 3 is correct. Option C is the correct answer. So can you tell me how you are getting Whitworth? Which link is being fixed in order to get Whitworth quick return motion mechanism? This combination is correct, right? But if I want to ask you which link you need to fix in order to get the Whitworth quick return motion mechanism, we need to fix the crank. The crank is being fixed, then only you are getting the Whitworth quick return motion mechanism, right? What about Oldham's coupling? It is a double slider. It is basically a double slider crank chain, right? So which of the links should be fixing in order to get the Oldham's coupling? You need to fix the connecting link. Connecting link should be fixed, right, in order to get the double slider Oldham's coupling. And if I talk about Scotch-Yoke mechanism, your one of the slider should be fixed. Slider should be fixed. Okay, right? Fine. We try to revise, like let us suppose if any option is incorrect, we try to identify what should be the correct answer for that also. Okay, next question. It's option C is the correct answer. And please do tell me at the end of the session, how many of you out of 20, how many questions have you marked it correctly? Okay, fine. Out of 20 questions, what is your final score? Next question. The center of gravity of the coupler link in a 4-bar mechanism would experience. We are having a 4-bar chain mechanism, right? This is the input. Let us suppose this is the coupler, right? This is your output and this is the fix. So tell me the center of gravity of the coupler link in a 4-bar mechanism would experience what kind of mechanism? No acceleration, no, only linear, only angular, both linear and angular acceleration. A, B, C or D. If you remember that, coupler actually is making a general plane motion. Coupler will be making a general plane motion. General plane motion, it will be having both linear as well as the angular acceleration. Option D is the correct answer. You know? Very good, Parth. Very good, Avnish. Naruto. Very good, Kiran. Done. Option D is the correct answer. Let's proceed for the next question. Question number 4 on the screen. Chaliye. From the gear train, a fixed gear having 200 number of teeth is meshed with the another gear having 50 number of teeth. Two gears are connected by an arm. The number of turns made by the smaller gear for one revolution of arm about the center of the bigger gear. So basically we are having a bigger gear and it is in a mesh with a smaller gear, right? This is gear number 1. This is gear number 1 and this is gear number 2. Let me take it as gear A and gear B, right? And this is being connected with the help of an arm, right? So they're asking you what is the RPM of gear B for one revolution of arm. Quickly tell me what will be the answer. Option A, B, C or D. 2 by 4, 3, 4 or 5. And you'll be getting only one chance to comment the answer, right? Okay. Okay, so Avinash is going with C, Kiran with D, Naruto, Parth, I think sufficient time is given. Yes, let us assume that we are giving X revolution to A, then B will be having minus X TA by TB, right? And you can add all the members with the arm revolution. So I can say NA will be equal to Y plus X and NB will be equal to Y minus X TA by TB, and the N of arm, that is equal to Y. Okay, fine. Now they are saying that the bigger gear is being fixed. That means the TA is, this is your fixed link, this is the fixed gear, right? So NA is equal to 0. I can simply say NA is equal to 0, that is X plus Y, and they are saying that we are giving 1 revolution for the arm. So Y is equal to 1. So if Y is equal to 1, X is equal to minus 1. We got the X and Y value, put it in this equation, get the value of NB. So NB is equal to 1 minus of 1, TA is 200, TB is 50. So this is 1 plus 4, that is 5 RPM. 5 RPM. So option D is the correct answer. Option D is the correct answer. Okay, clear? The gear B will be rotating about the center of gear A with an RPM of 5 revolutions. 5 RPM. Good morning. Done? Clear? Perfect. Option D is the correct answer. Okay, next question on the screen. In case of an involute tooth gear, the involute profile starts from which of the circle? Quickly. In case of involute tooth gear, the involute profile starts from addendum circle, dedendum circle, pitch circle or base circle. Apna score yaad rakhna. Please do remember your score. At the end, we'll be saying how many of you have given me the correct answer. B, okay. D, the involute profile starts from which of the circle? A, B, C or D? Simple question. Quick. Bhai sabhi log, I'll be giving you only one chance to answer. So D with Kiran, B with Vinod, D with Sun and D with Naruto. Majority have given me option D. Definitely option D is a correct answer. Option D is a correct answer. Very good. It's quite easy. Let us suppose this is one of the gear. This is a pitch circle. Let us suppose this is the pitch circle. Let's say gear A, pitch circle of gear A. This is your pitch circle of gear B. Pitch circle of gear B. This is the base circle. Base circle of gear B. This is the center. This is the base circle of gear A. Okay. If you try to join the word with the line of action, this with the line of action. This is the line of action. Something like this. Okay. This is your pressure angle. Phi. Right. And we know that the involute profile basically starts from this point to this point, and we always want the meshing should be happening between these two extreme positions, and that is the reason we call it as critical points. Okay, fine. So involute profile ka jo meshing hoga, it will be moving, it will be basically from these two extreme points. Okay, fine. So let us suppose this is point P, this is let us suppose L, this is M. So LP and PM, these are the two point L and point M are the two extreme ends in which we need to have the meshing, right? So definitely the involute tooth gear starts from the base circle, not the dedendum circle. Okay, clear? Now if I say this is the addendum circle, ये आपका gear A का addendum circle, this is the addendum circle of gear A and this is the addendum circle of gear B. Addendum circle of gear B. So your actual point of contact, आपका जो meshing होता है, that is basically happening between these 2 points. Okay, let's say this is K, this is P and this is L, right? So KP and PL, KP is a path of approach, PL is a path of recess, है ना? Or KL is a path of contact. Remember, right? But L and M are the two extreme points and you will be having the involute profile. Option D is the correct answer. We try to analyze every single question, right? Chaliye, next question. When two shafts are neither parallel nor intersecting, the power can be transmitted by using which of the gear? When two shafts are neither parallel nor intersecting, the power can be transmitted. A pair of spur gears, pair of helical gear, old M's coupling, or the pair of the spiral gear. A, B, C, or D. Neither parallel nor intersecting, without any doubt, option D is the correct answer. Spiral gears. We are using the pair of spiral gears to transmit power between two non-parallel and non-intersecting shafts. ठीक है? राइट, ऑप्शन डी इज द करेक्ट आंसर, नॉट बी। हेलिकल गियर तो आपका पैरेलल होता है ना, हेलिकल गियर्स वी आर हैविंग द पैरेलल, है ना। हेलिकल, व्हाट इज हेलिकल गियर? द टीथ्स आर एट एन एंगल, दैट इज हेलिकल गियर. Oldham's coupling, when the two shafts are having later misalignment, we are using the Oldham's coupling. Done? Okay, option D is the correct answer. Very good. Next question number 7. In the figure shown below, if the speed of the input shaft is 2400, I'll be showing the diagram. Okay, and the output shaft is 100. So we are having this as the output shaft. This is N4 is equal to 100 RPM and N2 is equal to 2400 RPM. They are asking that what is the module of gear number 4? What is the module of gear number 4? They are asking you. Quickly try this question and tell me what is the answer. What is the module of gear number 4? They have given you some combination of compound, or let's say riveted gear train. It's an example of a riveted gear train. Input and output are coaxial to each other. Quickly, there are some central distance given. The module of the lower gears, that is 2 and 1, are having 1 mm. Number of teeth is being given, but they are not giving, like if you want to calculate module, I need to calculate the number of teeth, है ना, आपको number of teeth निकालना पड़ेगा. They have given the value of T3 is equal to 10, T1 is equal to 60, T2 they have not given, right, and T4 also not given, because if I am able to calculate T4, I can easily calculate the value of M4. Yes, how to proceed? Central distance is being given. Central distance is being given, है ना? If I want to use M4, I can use M4, or we can say the central distance is equal to M4 by 2 into T3 plus T4. But here we don't know the value. See, central distance is given 35. 35 is equal to M4 by 2. T3 is 10 plus T4. I don't know the value of T4. So first of all, we need to get the value of T4. How we can get the value of T4? By using the velocity ratios. But velocity ratio के लिए भी you need to have the number of teeth of T2, है ना. तो पहले वो निकालते हैं. Sir, M2 is equal to, or central distance is equal to M2 by 2 T1 plus T2. Central distance is 35. 35 is equal to M2 is 1. T1 is 60. T2 we need to calculate. T2 is equal to 70 minus 60, that is 10. T2 is 10, right? Once you are getting the value of T2, we can use the velocity ratio to get the value of T4. क्योंकि T4 निकालते ही आपका M4 आ जाएगा. You can calculate the value of M4 over here. So what we can do, we can take the velocity ratio. What is the driver and driven? The driver, the input is this one, output is this one. So I can say N2 by N4 is the velocity ratio. So now we can see that 2 is driving 1. So T1 by T2 into 1 and 3 are compound. 3 is driving 4. So T3 by T4. है ना? No, ulta. T4 by T3. Yes? है ना? So N2, what is the value of N2? N2 is 2400. N4 is 100. T1 is 60. T2 already we calculated, that is 10. T4 we can now calculate. T3 is equal to 10. Chale. So from here T4 is equal to how much? This get cancelled out. This is 0. That is 40. T4 is equal to 40. So once you're getting the value of T4, we can now use this relation. 35 is equal to M4 by 2 into 10 plus 40. So from here M4 is equal to 70 divided by 50. That is equal to 1.4. Yes, 1.4 is option B is the correct answer. Kiska hua? How many of you have solved this question? Question was very easy. Question was very easy. Very good. Option B is the correct answer. Module for gear number 4 is 1.4. Okay, done? Can we proceed now? By next 20 minutes, we have to cover all the questions. Chaliye, next. Question number 8 on the screen. The center distance between two gears in terms of base circle R1, R2 and the pressure angle 5S. What is the central distance of the two gears? Sir, quite easy. Let me draw the diagram. This is your central distance of the two gears. This is your pitch circle. This is the pitch circle. And if you try to apply a smart work, you can eliminate all the options, you can get one answer. If you try to eliminate the options, है ना, आप easily answer निकाल सकते हैं. What's the unit of central distance? In length, mm या meter. A का unit देखिए per meter, not possible. C is dimensionless, not possible. D is dimensionless, not possible. Only we are having only one option. Option B is the correct answer. है ना? भाई simple सा logic लगाइए. Center distance का unit will be in terms of length. And if you try to visualize, you can eliminate three options, you can get the answer. Let us try to understand how we are getting this. So this is gear number 1, this is gear number 2, this is the pitch circle of gear 1, this is pitch circle of gear 2, this is your base circle of gear 2, this is the base circle of gear 1, right? This is the line of action of the force, something like this. Okay, now if you try to draw the R1, this is the base circle for gear number 1, this is R1. This is the base circle for gear number 2, that is R2. So this is, we have to calculate. This is your pressure angle. This is your pressure angle. This is phi. If this is phi, this is also phi. This is also phi. Hai so this is, we can say, what will be this distance? What will be this distance? This one, this is P. This is O2. This is O1. So I can say O2P is equal to, this is O2P will be equal to what distance? It will be equal to R2 by cos phi, and O1P is equal to R1 by cos phi. So central distance is equal to O2P plus O1P, that is equal to R2 plus R1 by cos phi. Okay, this is the central distance in terms where R1 and R2 are the base circle, radii of base circle. Okay, so here we are getting option B as the correct answer. Right, done, clear hai? Chaliye, next question, question number 9 on the screen. The turning moment diagram for a single cylinder double acting steam engine consists of positive and negative loops, and the above and below the average torque line. For the positive loop, what is the speed of the flywheel at the beginning and at the end? Which of the following is correct? Let us suppose I'm having the T theta diagram. I'm having the T theta diagram, right? Let's suppose this is the, your having the positive loop like this. Let us suppose we are having a positive like this is the positive loop. This is the positive loop. Okay. Let's say this is 1, this is 2. So they're asking the value of N1 by N2. Will it be less than unity, equal to unity, or greater than unity? At the beginning of the positive loop and at the end of the positive loop, what will be the ratio of RPM? Less than 1, equal to 1, or greater than 1, or 0? Quickly, I need answers from everyone. T theta. Okay. A, B, C, or D? A, B, C, or D? This is your positive. Okay, this is the positive one. Positive. Everyone is giving me equal hoga. Pakka? Sure. Sure. Less than unity, equal to unity, or greater than unity? 0 तो नहीं होगा. Chaliye, let me tell you one thing. Tell me one thing. When you are having a positive, that means your positive loop of in the T theta diagram, the energy stored by the flywheel will increase or decrease. मतलब energy store होगा, energy released. In the positive area of T theta, what the flywheel is doing? Is it storing the energy or releasing the energy? Energy is being stored, energy is being increased. So can we say, sir, let us suppose the kinetic energy is, the rotation kinetic energy is half I omega square, right? You're not changing the moment of inertia. If you're increasing or decreasing the energy, that simply means you're increasing or decreasing the RPM. Okay, so tell me at this point, at point number 1, are we just starting to store the energy? Yes, at point number 1, we are just starting. This is the energy storage being started, the start of the storage of energy, and N2 is the end of the storage of energy. So at N1, let's say I'm having this much of energy, slowly it will be increasing, it will be going all till N2. So can we say N1 and N2 will be having equal or unequal? Definitely it will be having unequal ratio, right? And we surely can say N1 पे आपका जो energy होगा, that will be less. Energy, the kinetic energy, the rotational kinetic energy at point 1 will definitely be less than that of rotational energy at point 2. That simply means the RPM at 2 will be more than that of 1, and they're saying that the ratio of beginning to the ending, so this will be less than unity. Option A is the correct answer. Option A is the correct answer. बहुत लोग गलत दिशा में सोच रहे हैं, क्या हो गया? Flywheel not studied. Not studied the flywheel topic. Energy का store होना, the energy storage is not stopping at this point. It is continuing till point 2. So if energy storage is increasing, so definitely we can say your kinetic energy is gonna increase. So N1 will be definitely less than that of N2. So this is the minimum. This is your minimum RPM. This is the maximum RPM, and that fluctuation of RPM. I hope so you have studied the coefficient of fluctuation of speed. है ना? The coefficient of fluctuation of speed you might have studied. That is the same thing over here. Clear hai? Understood now? Less than unity. Option A, less than unity, is the correct answer. Very good. Can we proceed? Any doubt, please do let me know. We can have a discussion, or else we can proceed to question number 2. Clear? Avnish, San, Naruto, Vinod, Kiran, Parth, everyone? Clear hai? Chaliye. Next question. I'm going to question number 10. Halfway. We have reached almost. Yeah. When the mass of the critically damped single degree of freedom is deflected from its equilibrium position, that means we are having, let's suppose this is the equilibrium. Yes. It is your equilibrium position or mean position, right? So if it is deflected from its mean position, we are having critically damped. What will happen? Return to equilibrium position without oscillation, oscillate with increasing time period, oscillate with decreasing amplitude, or oscillate with constant amplitude. Tell me one thing, in critically damped, do we have any vibration? No. In critically damped, there is no vibration. If there is no vibration, we won't be having any oscillation. Option A is the correct answer. Option A is the correct answer, because we know that the vibration is only present in the underdamped, right? Vibration is only present in the underdamped system, right? Matlab zeta is less than 1. But for there is no vibration if you are talking about critically damped and overdamped. Okay, there is no vibration present in this. Clear hai? Right? Okay, so option A is correct. Yes. So flywheel is work in energy storage, then realized is equal to work. Actually, what is happening in this case? The rate of storage of energy is, let's say at this rate, the energy storage is increasing. After this point, when it is reaching the maximum torque, the rate of storage of energy is gradually decreasing. That doesn't mean energy storage is total energy is not decreasing. अगर मैं बोलूं, I am moving ahead at a pace of 5 meters per second. Okay. After some point, I'm moving ahead with a rate of 3 meters per second. That doesn't mean I'm not moving forward. I'm still moving forward, but the rate at which I'm moving forward is decreasing. So can we say energy storage तो यहाँ पर भी हो रहा है, right? So energy storage will be ending at point number 2. That is the reason we are calling it as maximum RPM, and this is the minimum RPM. Okay, clear? Chaliye. Next, question number 11 on the screen. In the equation of a motion of a single degree of freedom, the system with viscous damping, we are having 4x dot, a double dot, plus 9x dot plus 16x equal to 0. What is the value of zeta? Option A, B, C or D? Option A, B, C or D. देखो यहाँ से ओमेगा वी कैन राइट इट लाइक दिस, x डबल डॉट प्लस 9/4 x डॉट प्लस 4x इक्वल टू 0. B, D, okay, combination of B and D. Quickly, what is the answer? A, B, C, D. Sir, we know that the standard formulation, the standard representation is x double dot plus 2 zeta omega n x dot plus omega n square x equal to 0. So from here I can say omega n square is equal to 4 or omega n is equal to 2 radian per second. Omega n calculated. Now we can say 2 zeta omega n is equal to 9/4. Zeta is equal to 9/4 into 2 into 2. 4 4 is 16. 9/16 is the final correct answer. Option B is the correct answer. Okay. Option B is the correct answer. That means your zeta is equal to 9/16. Option B. लिख के डिलीट करो यार. चलिए, I hope so now you are able to understand. Option B, जल्दबाजी में गलती नहीं करना, रैपिड फायर है, that doesn't mean that you have to overcome the calculation mistake. ठीक है, calculation mistake नहीं करना. ठीक है, you don't have to overlook the calculation mistake. आपको इसी पेस में ही you have to proceed, then only you will be able to cover all the question in the examination. In all the PSU, the main challenge the students are facing is not the difficulty, the time required for calculations or the time for completing the paper. That is the main challenge the students are facing. Difficult तो होता ही नहीं है PSU का पेपर यार. चलिए next, question number 12. If a spring mass dashboard system is subjected to an excitation by a constant harmonic force, that means we are talking about forced vibration. We are talking about forced vibration. Okay, they are saying at resonance, that means omega by omega n equal to 1. What is the amplitude of vibration? What is the amplitude of vibration at resonance? Infinity, inversely proportional to damping, directly proportional to damping, decreasing exponentially with time. A, B, C or D? Amplitude of vibration at resonance. What is happening? A, B, C or D? इतना simple question है. Force vibration. Apply the amplitude formulation and try to apply the resonance condition and tell me what is the correct answer. Is it infinity, or is it inversely proportional to damping, is directly proportional to damping, or decreasing exponentially with the time? Sir, we know the formulation. What is amplitude of vibration? That is equal to f naught by k divided by under root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Right, now we can say at resonance your omega by omega n is tending to 1. So at resonance the amplitude is equal to f naught by, this will be 1 minus 1 is 0, the whole square will be cancelling out, that is 2 into zeta into k. Now are they saying zeta equal to 0? Are they saying no damping? They are not said. It is having a spring also, it is having a mass also, and is having a dashboard, that is zeta is present. So if they are saying dashboard, that means zeta is not equal to 0. That simply we can say the amplitude of resonance is inversely proportional to zeta. That means option B is the correct answer. Option B is the correct answer. Only few students have given me the correct answer. Option B is the correct answer. Okay. If they are saying there is no damping, then we can say, let us suppose if they say if your zeta is tending to 0, then the amplitude at resonance will be tending to infinity. Then it will be infinite. Okay. अभी क्वेश्चन में उन्होंने ये नहीं बोला. They have not said that there is no damping. There is dash force present. There is a damping present. So definitely zeta is not equal to 0. Option B is the correct answer. Chaliye, question number 13. Let's proceed for question number 13 on the screen. In a force vibrations with viscous damping, that means there is a force vibration, zeta is not equal to 0. The maximum amplitude occurs when the force frequency is. The maximum amplitude occurs when the force frequency is A, B, C or D. A, B, C or D. Quickly. Quickly, in a force vibration with viscous damping, the maximum amplitude occurs when force frequency is when omega is equal to what? Equal to omega n, less than omega n, greater than that of omega n. Simple question. A, B, C or D. तब आपका amplitude is maximum. Simple question. Okay. A. Everybody is going with A. Pakka? Sure. Chaliye, let's try to identify. To answer to this question, we need to have an understanding of magnification factor. This is magnification factor on the y-axis. This is omega by omega n on the x-axis. Now, what is magnification factor? Magnification factor is equal to amplitude divided by f naught by k. That means if magnification factor is increasing, amplitude is also increasing. So, if you try to plot omega by omega n is equal to 0, then magnification factor is equal to 1. So, the graph will be starting it from this point. Okay. This is your resonance. Omega by omega n is equal to 1. This is your resonance condition. If I try to plot the graph, it is something like this. If you try to plot the graph, it is something like this. This is for zeta greater than equal to 1. This is zeta, let's say 0.4. This is zeta is equal to 0. Now, in the question, they are saying that in a force vibration with viscous damping, that is zeta is not equal to 0. Zeta is not equal to 0. That simply means we are not dealing with this curve. So, for maximum amplitude, it is always less than that of omega n. Even if you are plotting other graph, then we are getting the maximum amplitude at less than that of this. Okay, so the correct answer is slightly less than the natural frequency. It is not A. It will be maximum when omega is equal to omega n if there is no damping. No damping पे आपको यहाँ पे maximum होगा infinity. But if there is a damping present, then definitely the maximum amplitude will not be at the resonance or at omega is equal to omega n. It will be slightly less than that of that. Okay, so option B is the correct answer. So see, read the questions carefully. These type of mistakes do commit in the examination. Students do commit. Okay, because we are having a we can say common perception that sir, when omega is equal to omega n, we'll be having the maximum amplitude. This is only possible when there is no damping. If there is damping, then that maximum amplitude will be slightly less than that of omega by omega n. Clear hai? Understood? Chaliye, next question, question number 14th on the screen. A rolling disc of radius E and mass m, radius R and mass m is connected to one of the linear spring stiffness K as shown in the figure. What is the natural frequency of oscillation? What is the omega n value? What is omega n value? Simple, we can use the energy equation to calculate the natural frequency of vibration. We can use the energy equation and get the final answer. Very good. Very good. Correct. Anyone else? Parth has given me option A. Anyone else? So we can use the energy method. We can use the energy method over here. What is the total energy? So total energy is equal to half mv square plus half I omega square plus half k x square, right? So this is half into m into v square plus moment of inertia of a solid disk. This is this mr square by 2, mr square by 2 omega square plus half kx square. So this is we have 1 by 4, that is 3 by 4 mv square plus half kx square. Okay, and we know that the rate of change of total energy with respect to time is equal to 0. So from here 3 by 2 mv into a plus k into x into v equal to 0. So from here I am getting 3 by 2 ma is plus k into x equal to 0, or mx double dot, or we can say x double dot plus 2k by 3m into x equal to 0. So omega n square is equal to 2k by 3m, or omega n is equal to under root of 2k by 3m. Okay, 2k by 3. right? So we are getting the final answer at 2k by 3m. Option A is correct. Usually we need to remember these particular formulation. It will be helping us to save the time. ठीक है, instead of going for the derivation, आपको basic पता रहना चाहिए if they are asking a question like this, right? This is a direct formula based problem. चलो, question number 15 on the screen. The nature of governor is shown by the graph between the radii rotation and the controlling force F. Which of the following is an isochronous governor? For an isochronous governor, which of the following graph is correct? We know that there are three possibilities in a isochronous governor for a spring control. So this is your radii rotation, this is your FC. There are three straight lines. Okay, fine. This is for isochronous, this is for unstable, this is for stable. Right. So here option C is the correct because it is passing through origin. This is for a either Watt or Porter. Right? These are the straight line is basically for the spring controlled governor. This is unstable. That is FC is equal to AR plus B. This is a stable governor. That is FC is equal to AR minus B. Okay, fine. This is your isochronous governor. That is FC is equal to A into R passing through origin. Option C is the correct answer. So next question number 16th. If the ratio of the length of the connecting rod to the crank radius increases, if L by R ratio increases, then what is happening to the primary unbalanced force and secondary unbalanced force? What is the formulation we are having? If the L by R ratio is increasing, which of the unbalanced force will increase or decrease? We know primary unbalanced force, that is mr omega square cos theta, right? Because this L by R is nothing but the obliquity ratio. This is N, this is your obliquity ratio, right? And we know that obliquity ratio is only coming under the discussion of the secondary unbalanced force, that is mr omega square cos 2 theta by N. Mr omega square cos 2 theta by N. If you try to increase the value of N, the secondary unbalanced force is gonna decrease. There is no change in the primary unbalanced force. Option D is the correct answer. Option D is the correct answer. Clear hai? Yes, option D is the correct answer. Chaliye, question number 16 ke baad, now let's proceed for question number 17 on the screen. Okay, a question from the balancing. Masses B1 and B2 are attached in a shaft in a parallel planes as shown in the diagram below. You have to tell me, if the shaft rotating 100 rpm, what is the mass B2? What is the mass of this B2? This is B2. Now they are saying this is a definitely we are talking about the balancing, so we can take moment about this plane. We can take this as the reference plane. We can take this as the reference plane. And we can calculate the moment. These masses are rotating at some radii, so we'll be having some force over here, we'll be having some force over here. We can take the moment of this force about the reference plane and make it equal to 0. This F1 will create an anti-clockwise, F2 will create a clockwise. So we can say this is 9 into mr omega square, 50 into omega square into 50 is equal to B2 into 50 into omega square into 150. Okay, so this completely get cancelled out. So 9 into 50 by 150 is equal to B2 mass. This is equal to how much? 3 kg. 3 kg is the mass of this B2. Option A is the correct answer. Simple, eh? Whenever you are getting balancing, there are two possibilities. Either will be having static balancing or dynamic balancing. Static balancing ka matlab masses are rotating the same plane. There we can only take the net force equal to 0. Force polygon we can draw. But if I talk about the dynamic balancing, the masses rotating in the different planes. In that case, you have to check for the moment balance and the force balance. Both conditions should be this one. Okay. B1 equal to B2, that we have to check. You can take the reference plane at B2, calculate. You take reference plane at B2, calculate B1. It won't be equal to 3 kg. It won't be equal to 3 kg, I think. Please do check. It will be 9 into 100 by 150. Okay? or we can say B1 plus B2 is equal to 9. If I want to calculate B1, sir, B1 plus B2 is equal to 9. So B1 is equal to 6 kg. Option B. Simple. By total force, what up, total force downward. What is the force? Force is mr omega square. है ना? Radius सबका same है 50, 50, 50. Omega, because they are mounted on the same shaft, omega भी same है. So only deciding factor is mass. Okay, fine. Clear है? Done. चलिए, question number 18 on the screen. A wheel is having a radii r, rolls without slipping. This is important. On a horizontal surface, if the center of the mass P is having a velocity, it is having a velocity of 8 meter per second in the horizontal direction towards right. The magnitude of the velocity at a distance r by 2. What's the velocity at point Q? Can you tell me? A simple question. You can apply the concept of I center also. Quickly, what will be the velocity at a distance Q? At Q, which is at a distance of r by 2 from the center. This is r by 2. R by 2. Sir, we know that whenever a body is having pure rolling, its I center is located at the point of contact. So we can say the velocity at point Q is nothing but Q point I into omega. Fine. And they have given you V because this is pure rolling. So V is equal to R omega. Omega is equal to V by R. So here Qi is R plus R by 2, that is 3R by 2 into omega is velocity is kitna? 8 divided by radius is R. So R and get cancelled, that is equal to 12 meter per second. Option C is the correct answer. Option C is the correct answer. Very good. Very good. Very good. Chaliye, done. Next, question number 19th on the screen from the topic of gear train. In a compound gear train, there are 6 gears, namely A, B, C, D, E, F, and the number of teeth is given, that is 24. This is 24. TA is 24, TB is 72, TC is 30, TD is 90, TE is 18, and TF is 72. They are saying what is the angular speed of the driven to the driver. That means NF by NA. This ratio they are asking. That means the reverse of velocity ratio, the inverse of velocity ratio. If I am able to calculate the velocity ratio, my problem is solved. Okay. Now we can write. There's a simple technique to answer to this. Sir, what is velocity ratio? That is the n of the driving to the driven. Driven, right? What is n of driving? Driving is A, NA by the main driven is NF, right? Now, to answer to this question, we can use a simple technique. The product of the number of the teeth of the driven gear to the product of number of teeth of the driving gear. Now, if you see, A is driving B, so A is driving B, so TB by TA into B and C are compound, leave it. C is driving D, so TD by TC, TD by TC into E and D are compound gear, E is driving F, so TF by TE, TF by TE. That's it. So NA value we have NA by NF we can calculate very easily. TB is 72, TA is 24, B is 30, C is 30. We write it over here. TC is equal to 30, TD is equal to 90, TE is equal to 18, and TF is equal to 72. Right. So C is 90 by C is 30. F is 72, E is 18. 72 by 18. So what is this value? So we are getting this is 3, this is 3, this is 4. So 9 into 6. They are asking you which? They are asking you the question of NF by NA. So NF by NA is equal to 1 by 36. Okay, they are asking NF by NA 1 by 36. Option D is the correct answer. Right? Option D is the correct answer. Option D is the correct answer. Done? Very good. Last question. Then I'll be asking you a number of questions that you have marked it correctly. There are two lists, list 1 and list 2. Which of the correct is the correct combination of list 1 and list 2? 4-bar chain, Grubler's criteria, Scotch-Yoke mechanism, and pantograph. On the right hand side, we are having simple harmonic motion, Grashof linkage, enlargement, and the degree of freedom. Quickly. Which of the following list 1 and list 2 is correctly matched? There are different codes being given. Quickly. Now, we know that pantograph is basically used to enlarge any shape. Pantograph, you might have seen that we are using in many applications, drawing also. So we are using to enlarge any shape. So D is having 3. D is having 3. Scotch-Yoke mechanism, an inversion of a double slider, and it is having a simple harmonic motion. It is actually creates a SHM. So 1. B. Okay, we are going with B. 4-bar chain. Now we are having left out with Grashof linkage and degree of freedom. Definitely we can say that whenever we are dealing with your 4-bar chain, we are talking about the Grashof linkage, and Grubler's criteria is being used to calculate the degree of freedom, that is 4. So 2413 option B is the correct answer. 2413 option B is the final correct answer. Okay, fine. So these were the top 20 questions which has covered almost every topic we have touched from examination perspective, the rapid fire rounds in which we have covered all the questions. And we'll be coming up live from 18th, like after Independence Day on 18th of August, we'll be coming up live with the previous year questions from 21 to 23, all technical questions. This will be helping you out in the multiple examinations. Okay, so do join us from 18th, and from 8th of August onwards, we'll be starting the MSQ series for GATE 2024. It will be bilingual, Hindi, English, dono mein discussion hoga. Okay. It's fine. And to download the different PDF, we are having link in the description. Along with that, to attend the scholarship test, you can do join us on the link which is given in the description. Okay, so thank you guys. I hope you all enjoyed this quick rapid fire round for ISRO examination from the subject of theory of machine. So I hope you liked. Please do like this video and do share this video to all of your friends. And let's meet in the next session. Till then, enjoy your learning with BYJU'S Exam Prep. Thank you guys. Bye bye. Take care. Stay safe and enjoy your day. Thank you.